Okay, I am so sorry for the way that last video ended. Oh snap. Okay. Not the most tech savvy, but I'm able to help you, so we'll do our best. Okay. So we just did factoring. So now we're going to be finding zeros of polynomial functions. Okay. So, pretty much, if we have a graph here, and let me do that. Zooming in on this graph a little bit. Oh, I was wanting to do a different color. Oh, snap. Okay. Boop. There we go. Why is it not letting me do green? I want to do green. Okay. I guess I'm not able to pick different colors right now. So these right there are going to be what your polynomial functions are. Oh, that's why. How do I get rid of that? I don't know how to get rid of that. Oh, delete. Okay, there we go. Cool. Now I can probably change colors. Haha. So here, 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 and here. Well, here's the thing. Those are only going to be the real numbers, which I'll get into that. So where y equals 0, that is a polynomial function. Okay, so if something says nth degree, this refers to the largest exponent. I don't know where that stopped. Okay, wait, okay, I don't know what just happened, but the nth degree refers to the largest exponent that the x has. It also is how many roots you will have. Okay, so for example, p of x, which this is just one way to say a function. So the function p of x is x to the 5th plus 9x3 minus 2x3 minus 18x. So our exponents are 5, 3, 3, and 1. So this is going to be, I'm going to write it in red, a 5th degree polynomial. Okay, I keep hitting buttons from my laptop, and I don't know if, because it's on my lap, but anyways, okay. So 5th degree polynomial, so that means it has 5 answers. Okay, that can be real or imaginary. Okay, so real is going to be what's shown on this graph. So like those y equals 0, those y equals 0. So they are real roots. And that's just an example. So let's look at this with like the actual equation up here that I gave. So we're going to take this. We'll move it down. Handy dandy. We're going to go ahead and erase. Can I erase? Okay. I'll add those back. Okay. 5, 3, 3. Okay. We're going to factor this. So to factor this, we're going to look at first greatest common factor. Well, guess what? All of these have an x. So we have a greatest common factor of x. So then we're going to have x4 plus 9x squared minus 2x squared minus 18. Okay, well, we also have like terms, which you can do these two interchangeably, but so we have like terms right here. We have negative 2x squared, positive 9x squared. So we can go ahead and write that out with x4 positive 7x squared. Wait, that's not what they did. Wait, okay, wait. You can do that. There's an easier way on this one. And it's like, what was I doing? Come on. Okay, that took the 2. There's an easier way than doing like terms. So the next thing you're going to do, factor by grouping. So we're going to look at these two. So we have x to the 4th plus 9x squared negative 2x squared minus 18. Now we're going to do the exact same thing. And then all of this is in with x, which I'm going to go ahead and change the color of this so we know that this has already been factored in. So now we have x, and we are going to look at this one. So we have x squared as a greatest common factor, right? And that leaves us with x squared plus 9. Okay. Now we're gonna do, we'll do pink. So then with this one, remember above whenever I said that we want to always try to get out negatives, that's what we're going to do here. So we're going to take out negative 2, and that's all we can take out. So negative 2, that leaves us with x squared. Once we factor out a negative 2 out of 18, that leaves us with positive 9. Well, looking at this, oh, wait, we don't put something. Look at that. Now we have like terms again. So we have x, parenthesis, x squared plus 9, and that'll take care of that and that. Let's look at what's left. We have an x squared minus 2, x squared minus 2. Okay? So we have all of that. So now, if we're finding the zeros, we have to set these equal to 0 to find them. So we have our first factor right here, and that's so x equals 0. Well, bam, there's one of our roots automatically. Then we have x squared plus 9 equals 0. And then we have x squared minus 2 equals 0. Okay. Well, remember whenever I said the up here, the nth degree, that's how many roots you'll have. So in this equation, we should have 5 roots. Well, right here, we only have 3 equations, and I will explain why. So when we go to set these to 0, we're going to have x equals 0. That is one of them. X squared plus 9 equals 0. So that's x squared equals negative 9. Then you take the square root to get rid of that take the square root. This does not exist. And we can think about our multiplication rules. We know a square number equals a number, number n times n. Okay, so if we have a positive n times positive n, that's going to get us a positive n squared, right? Or like a positive, another positive number. Negative n times negative n will still get us a positive n. So we can't have it. So we'll come back to this, okay? Maybe it might have to be in the next video, but we will come back to it. So let's look at our other ones. We have x equals 0. We have this, so we're going to go ahead and highlight. And then we have x squared plus, oh wait, minus 2 equals 0. X squared equals 2, square root, x equals square root of 2. This can be, just like we talked about down here, positive or negative. And so I don't remember how to write it out, but like if, let me figure out what the square root of 2 is right quick. Oh dear. I don't know how much time. Okay, sorry, I did not know how much time I had, so I wanted to make sure I was okay with time. So 2, square root of 2 is approximately, so whenever you do approximately, you kind of do this little notation. 1.414. Okay, well, this number right here can be positive or negative. So there, in this equation, you have two answers. Because it can be positive or negative, okay? So we know we have x equals 1.414, approximately x equals negative 1.414, x equals 0, but we still have two more because we know it's a fifth degree polynomial, so we should have 5. I'm going to stop here, and then I am going in the next video to go over this, and that should be my last video. So